In this video, we are going to finish up our discussion of lines in 3 space before we move on to planes. So we have the same setup as last problem, looking at two lines and trying to find their intersection. We also have some other stuff that we're going to have to do, so this problem is going to be quite long. We have to find the angle between the two lines that intersect, and then we also want to find where line 2 crosses the coordinate planes. We'll get there. So we have 3 problems: 1, 2, 3. I would recommend doing this for tests. I've had so many people on tests not do that, and they'll answer problem 1 and then not answer the remaining of the question. They miss a lot of points for something they probably just didn't even realize they did. All right, so number 1, this is just like the last example. Now, the only thing that kind of bothers people is they don't like symmetric form, and that's fine. I don't mind it; doesn't bother me. So we will write this in parametric. What I do is I look at here and I just solve. So I think about if that was equal to t. Okay, so I would add 2. So I'd have a positive 2, and then I would my directional number is 3. So it would be minus 3t. Y is positive 2 plus 6t, and then z is 3 with a t, positive 1, because it's over 1. I could do that, right? Over 1. That's L1. L2, x equals, 3 plus 2t. Y equals negative 5 plus t, 1t. You could put 1. And then z is negative 2 plus 4t. Okay, so there are my 2 lines. We need the directional vectors because remember the first thing we want to do is check and see if they're parallel. We're going to need these directional vectors anyway. Okay, so we get for the first line, negative 3, 6, and 1. For V2, we get 2, 1, and 4. All right, you can tell that last one has to multiply by 4 to get from 1 to 4 in the z component. That's not going to work, so these are not parallel. Remember, we're just checking the constant multiple. There is no number I can multiply by v1 to get v2, or vice versa, v2 to get v1. So these are not parallel. So the next thing we do is check for intersection. All right, check for intersection. And how we do that, remember, we're trying to find is there an x, y, and z, or t1 and t2 that would make all that true. So I'm going to write down x is equal to x's. Also writing y is equal to y's. And then z's are equal to z's. Forgive my bad handwriting. They'll get better once I start getting used to this iPad again. Okay, so I have 3 equations, 2 unknowns. Oh, we should have T1, T1, T1. We should do that up here. T1, 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 T2, 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 because they're different T's. These are also different X's, so we really should have X1. That's okay, though. So we have our T1s and T2s. And I'm trying to use 2 equations to make one. I always end up using the top and the bottom for some reason. I'm going to write down the top one. And my goal is I'm going to knock out those T1s. So I want to multiply this bottom equation by 3. So I got 9 plus 3t, 1, equals negative 6 plus 12, t2. All right, I did that so the t1s would go away. I add my equations. All right, there's that equation. Now I can solve for t2. T2 ends up being 1. Now I plug that into my other equations. 2 minus 3. I plug in 1 equals 3 plus 2t2. On the left side, we got a negative 1 equals 3 plus 2t2. I imagine that you, I plugged t2 in the wrong one. Okay, so we got to go back. You probably caught that as I was doing it. This is t1. T2 is 1. There we go. If you work this out, we get t1 equals negative 1. Okay, so now we check the remaining. So the remaining, okay, I got t1 equals negative 1. I got T2 equals 1, and I picked the remaining equation, which is 2 plus 6T1 equals negative 5 plus T2, and we plug all that in. 2 plus 6 times negative 1 equals negative 5 plus 1. And we're wondering, I should put an equal question mark above because we're curious if is it going to work out. So, okay, that ends up being, on the left side we got negative 4. On the right side we got negative 4. So that means they do intersect at T1 and T2. So if I want to get a time now, okay, x equals, and I just go up and use one of the lines. All right, I'm going to use T1 on the L1. So I got x equals, all right, that ends up being a 5. Y is 2 plus 6 times T1. T1 was negative 1. That's negative 4. And then Z, that last one is 3 plus T1. That's going to end up being 2. So they intersect at 5, negative 4, 2. All right, so that's how you check and show that two lines intersect. Recap, we checked to see if it was parallel. It was not. That's what we did up front. We did write them down first in parametric. My handwriting is looking pretty bad. It will get better. Just give me a few lessons. The check for intersection, what we're doing first is we just took two lines from there, made sure where if I added down, one of the t's would go away, solved for one t, plugged it in to get the other t. What we did is we showed that a t1 and t2 would make our x's and z's equal. As long as t1 is negative 1 and t2 is 1, x's and z's would be equal. What we did here at the end is to check to see if it would be equal also for y. Plugging it in, we showed that, hey, the y's work as well, which means that the two lines intersect when t1 is negative 1 and t2 is 1. So we pick t1 to plug it in here to get that point. We also could have plugged T2 into the L2 and you hopefully would end up with the same point. If you don't, then you did something wrong. All right, so this is why I labeled everything up front. We just answered number 1. Number 2 says find the angle between. So we are going to do that now. So the angle between, we need to think about it for a moment. Let's think about the directional vectors. Think about V1 and V2 for these lines. If I have V1 and V2, the angle between my V1 and V2 should be the angle between my lines as well, because V1 and V2 actually run the same direction as that. So I'm going to write that down. Angle between lines equals angle, and you can write this better probably, angle between directional vectors. Out of room. Vectors. Angle between lines is an angle between directional vectors. Okay, so if I have an angle between vectors, let's recall the definition for this. Cosine of theta equals A dotted with B over the magnitude of each, the product of the magnitudes. There we go. All right, so there is my definition of that. Let me write that a little better. Start working on getting my handwriting better on this iPad. There we go. All right, that is that. So using what we have cosine of theta is equal to V1 dotted with V2, and then my magnitudes on the bottom. From the last problem, let me write that down. We had make sure I grab the right one. Yeah, so here's V1 and V2. You may have them in front of you. I just had to turn my page. So we had negative 3, 6, 1. And we also had V2, which was 2, 1, 4. Okay, so we need several things from this. We need the dot product, so let's go ahead and do that. The dot product of V1 dotted with V2 is negative 6 plus 6 plus 4, which ends up being 4. Okay, now we also need the magnitude. So the magnitude of V1, square root of 9 plus 36 plus 1. That ends up being 45, 46. The magnitude of V2 is the square root of 4 plus 1 plus 16, which is the square root of 21. Plugging that all in, we have cosine of theta equals, okay, and let's do absolute value so we get two angles from this, but if I just let it be positive, I'll get the acute angle. So I got that times my magnitudes. All right, so we have cosine, and we already had the absolute value for that 4. I guess we didn't need it. But if it's a negative, we'd want to use a positive. Okay, so we now want to find theta. Theta is approximately, and we just do the inverse cosine of that. If you multiply those, you get 966. This gives me roughly 82.6 degrees. If you, we'll leave it at that. If you had a negative up here and you plug that in, you're going to get obtuse. You should know this, hopefully. That's a good review for your test, that if A times B, A dot B, right? Remember, if it's positive, then it's acute. If it's negative, then it is obtuse. And then if it's 0, it's a right angle or it's an orthogonal angle. All right, so we have one more thing here we're going to squeeze in. Not writing with a highlighter. So finding, let's change colors because it's getting pretty overwhelming for my brain anyway. Find crossing of coordinate planes. What they mean by coordinate planes, in case you don't know, is like the XY plane, right? Or the XZ plane, or anything like that. It's the zeros, right? So XY plane. Think about the XY plane here. The XY plane happens when Z is 0, right? If Z is 0, let me make that Z a little better. If Z is 0, not much, but if Z is 0, then we're at the XY plane. It's the ground. If we think about our axes like that, right? It's the XY is the flat part while Z goes up and down. So if that happens and we let Z equal 0, then we use our line definitions that's on the last page, that's up here. So we're looking at line 2, that's all they asked for. Also, find where line 2 crosses the coordinate planes. So this line 2 has this here. Here, we can just do this. Copy, I'll put that down here just for a minute. That's what I get for L2. So if Z is 0, we get we get 0 equals negative 2 plus 4t2, and we'd solve for t2. T2 happens then at, I add 2, I divide by 4, at 1/2. So it actually crosses the plane. I just plug in t2 for all these values. When I do that, it crosses at 4, negative 9 over 2, and 0. What we're doing is we are taking this number 1/2, and we put it right here, 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 and that gets me an XYZ. So that's what we just did. So what this means is that this line, remember this is a line in red down here, L2, it will cross the XY plane at this point. So it will go, if you think about some line crossing, it's going down, right when the flat ground, it's going to cross at that exact point. All right, so that's when that crosses that axis. We can also do the other ones. I have XY plane, let's do the XZ plane. So notice if we use the pattern from above, XY plane, we set Z equal to 0 because Z wasn't there. So here, it makes sense to set Y equal to 0. So this is the XZ plane. So I take my Y line and I set it equal to 0. This tells me T2 is 5. So if T2 is 5, gosh, sorry, my handwriting is. T2 is 5, then I would plug T2 in all those T2s right here in L2, and that would give me the point 1308. I'm going to let you check that plugging it in. All right, let me move this down. It's going to go right there. And we got one more plane. We have an XY plane. We have an XZ plane. We also have a YZ plane. The YZ plane, you could probably guess this, we would set the missing variable, x equals 0. I use the L2 that's down here, right? 0 equals 3 plus 2t2. If I solve for t2, we get negative 3 over 2. Plugging that in for each 3 over 2, we get the point 0, negative 13 over 2, negative 5. So if we want to find where it crosses those planes, we just set the corresponding value, the one missing from that plane, equal to 0. We solve for the t2 or t1, whatever the t may be. Then we find that t, plug it back in, it tells us the point. Not too bad. The angle stuff, use a calculator for this jump. Hopefully you didn't get caught back there. This is just a calculator thing. Make sure it's in degrees.